Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Student, this is question number 10, NEET physics paper 2015. Hello students, let us solve question number 10. It says a particle of unit mass undergoes one-dimensional motion. Particle of unit mass undergoes one-dimensional motion such as its velocity varies according to this. Okay, velocity varies according to this. So this equation for velocity as in terms of displacement is given by beta x to the power minus 2n, where beta and n are constants. This beta and n are constants and x is the position of the particle. The acceleration of the particle as a function of x is given by. First of all, we have to understand one thing. If we are given v as a function of x, and we are asked to find a as a function of x, then how will you do? The interesting thing is that v as a function of x, if v is a function of t, then we differentiate that to get a, because a is dv over dt. So if this is a function of t, then I will differentiate this to get a as a function of t. But here the v is as a function of x and we want a as a function of x. So first of all, we have to find the formula for a as a function of x, and we know that a can also be written as dv by dx into dx over dt. Okay, because this dv by dt is there, I just have multiplied dx and dx there, so this becomes v, and therefore this becomes v dv over dx. This is another formula for acceleration in terms of x. So dv by dx into v, that is v dv by dx. So if we are interested to find acceleration, then you have to use this formula. So our acceleration as a function of x should be v dv over dx. V is given as this, so I'll just write this value here, but then I will differentiate this v, equation v, with respect to s. So first of all, let us do that. Phi of x is beta x raised to the power minus 2n. So what is dv by dx? So dv by dx will be, this beta will be there, and derivative of this is x raised to the power minus 2n minus 1, and derivative of this is minus 2n, so minus 2n is there, multiplied. So this is equal to minus 2 beta n x to the power minus 2n minus 1. Okay, so this part is okay now. This part we are getting this value, and what about this part? This part is given in the question, that is this one. So this acceleration as a function of x can be obtained as v, that is equal to this one, beta x to the power minus 2n, and dv over dx, that is this one, that is minus 2 beta n, this is multiplied with this, and x to the power minus 2n minus 1. These are all multiplied. So this and this multiplying, this will give you minus 2 beta square n. Okay, this is beta square, n is there, x to the power minus 2n to the power minus 2n minus 1. So it will add up, and this will give me minus 2 beta square n x to the power minus 4n minus 1. This is what is the acceleration as a function of x. So if I see the options, then minus 2 beta square n, minus 2 beta square n, n is not there, this is not right, n is not there, this is not right, minus 2 beta square n x to the power minus 4n minus 1. Here it is not minus 4n minus 1, this is not right. Here it is minus 4n minus 1, this is right. So this is the right answer to this question. Okay, thank you.